dimension of different quantities. So this dimension is just in form of a subtopic under unit and its measurements. Are you getting it? Okay. So now I believe you might have come across um this type of thing, right? Like MLT 0 or LT raised to minus 2 or LT raised to minus 1, right? I believe you might have come across this type of thing. Now, all these are called dimensions. Are you getting it? All these are called dimensions. Now, you see this type of question during your test and exam. Are you getting it? So all these are dimensions of different quantities. It can be the dimension of fundamental quantity or the dimension of derived quantity. Are you getting it? So I want to explain in detail on how you can calculate the dimension of any quantity so that when you come across this type of question, either uh, during test period or exam, you can easily answer it. Okay. Okay, let's start with this quantity. Please, I'll be starting with the most simplest ones. Are you getting it? I'll be starting with the most simplest ones. Gradually, we will getting to more complex ones or other ones. Okay. Now, let's start with this quantity, which is area. Let's say you are asked, what is the dimension of area? Please listen carefully. Listen carefully. Okay. Now, whenever you are asked to derive or solve for the dimension of any particular quantity, the first thing that will come to your mind is what is the formula of that particular quantity. That should be the first thing that should come to your mind. Are you getting it? Whenever you are asked to find the dimension of any particular quantity, I said what? The first thing that should come to your mind is what? The formula of that particular quantity. Are you getting it? The formula of that particular quantity. That should be the first thing. Okay, let me write it down. Number one should be the formula. Are you getting it? That should be the first thing that should come to your mind. Now, number two thing that should come to your mind is the approved storage quantities. Now, we have length, mass. Okay, let me write it here. Length, mass, and time. And time. So we are going somewhere, okay? Keep watching. So what is the symbol of length? Symbol means the first letter. Are you getting it? If I say what is the symbol of Steven? S is the symbol of Steven. Are you getting it? The first letter. Are you getting it? So what is the symbol of length? The symbol of length is L. The symbol of mass is what is M. And the symbol of time is what is T. So writing down the dimension or calculating for the dimension of any particular quantity, I said what? The first thing that should come to your mind is what? The formula, right? That should be the first thing that should come to your mind. Secondly, the second thing that should come to your mind is these three approved quantities. All these are fundamental quantities, right? Length, mass, and time. They are under fundamental quantities, right? Now, listen. When writing down the dimension of any particular quantity, these are the three approved quantities used in writing down the dimension of any quantity in physics. I get me. Is it the dimension of acceleration, dimension of energy, dimension of Young modulus, uh, dimension of momentum, impulse, any dimension, all the dimensions in physics. These are the three approved quantities used in writing down of any dimension. Are you getting me? Now, I will explain everything for you to understand. So please keep watching, okay? So note, take note of these two things. The first one is the formula, and please don't forget these three things. These are the that is The first one is what? Length, mass, and time, right? And these are the symbols. These are the symbols we are going to be using in writing down the dimension. I get it. That is length, mass, and time. Okay. So from the question, let's start from this one. So now, let's say we are in exam, this thing. This is an exam question. Now they gave you this one. Now let's say you are given this type of question. Write down the dimension of area. I said what the first thing that should come to your mind is what is the formula, right? Now ask yourself. That's why as a physics student you have to know formulas. As a science student, sorry, you have to know formulas. Yeah, it's very important. Whether you are dealing with chemistry, math, physics, you have to know formulas. If not, you'll be confused with a lot of things. I get me. Okay, so these are the basic things you should know or understand before moving higher to complex things. I get it. Because any calculation in physics, you need formula. Any calculation, all the calculation in physics, you need formula. Are you getting it now? So now I said the first thing that should come to your mind whenever you are given a particular question under dimension is what? Formula, right? So ask yourself, what is the formula of area? So the formula of area is what? Length times breadth, isn't it? Here. Area is what? Length times breadth. This is the formula of what? Area. Okay. Now take notes. I said writing down the dimension of any quantity in physics. These are the approved quantities, right? Length, mass, and time. I get me. So no matter any symbol you see here, you have to change it to either length, mass, and time. They must correspond with these three symbols or these three quantities. Are you getting it? Whether you will see P in what you are solving, whether you see Q, any alphabet you will see, you have to change it to any of these ones. Okay? So please take note. Now let's continue. So this is the formula of area, right? Area is what? Length times breadth, right? Now from these three symbols or these three quantities, we've gotten length, right? Length is already here. Now, is breadth here? No, breadth is not here. Isn't it? There is no B here. B stands for breadth now, length times breadth. This one is length. We've gotten length, but B is not here, which is breadth. So what are you going to do? I said you have to change everything to correspond, right? You have to change everything to be in this form. Now, meaning that, let me ask you, should breadth be length or should it be mass or should it be time? Breadth should be length. Breadth should be in length. Yes, because length and breadth are still the same thing. Are you getting it? Length and breadth are still the same thing because all of these two quantities are measured in meter. Breadth, height, length are all measured in meter. Are you getting it? So you have to understand this aspect of changing to these approved quantities. Are you getting it? This is one of the concepts you have to understand. Okay, so we have length here and breadth. Okay, breadth can be written as length. Yes, so it will now be length times what? Length, isn't it? So length times length is what? Is length square or L square. L times L is what? Is L square. So look at it. Now, most of you, when it comes to this multiplication and addition aspect, most of you are confused. Like where to add, where to multiply. Now, supposing we have L plus L. L plus L is not L square. Are you getting it? Now look at it. These two alphabets are the same. They are the same things, right? Let me see. B plus B, C plus C, A plus A. You can see that all of them are the same, right? And we have plus here. So when two alphabets when two the same alphabets are adding, like when you see this type of question, in a case where the two alphabets are the same and the middle the middle is plus or addition. Addition is still the same thing as plus. So if the middle is plus and the two alphabets are the same, it will now be what? 2L. Are you getting it? L plus L, it will now be 2L. So B plus B will be what? 2B. C plus C will be what? 2C. A plus A will be 2A. Are you getting it? Now, but look at this one. This one, the two alphabets, are they the same or not? Are they the same or different? They are what? The same alphabet, right? But the middle is not plus. The middle is multiplication. So meaning that it will not be 2L. Since the middle is not this thing. Since the middle is not addition. Okay. Yeah. Here the middle is times, right? So meaning that it will be L square. So meaning B times B will be B square. C times C will be C square. Are you getting it? But C plus C will be 2C. So please take note of these two differences. Okay. So this is the dimension of area. So you see how simple it is, right? So please, if you don't understand, you can rewatch the video. But I know with this explanation, you've understood everything. Now, this is how to calculate the dimension of area. First, take note of the formula. That should be the first thing that should come to your mind. The second, take note of these approved theory quantities. Are you getting it? Okay, let's solve for the second one. Let's say you are asked to find the dimension of volume. Are you getting it? You are asked to find the dimension of volume. Now look at it. Dimension of volume. I said the first thing that should come to your mind is what? The formula, right? Now ask yourself, what is the formula of volume? Now you know volume is length times breadth times height, isn't it? This is the formula of volume. So you have to know formulas, it's very important. Yes, you have to know formula, it's very important. I get it. So length times breadth times height, right? I said before, right? I said these are the three approved quantities. So meaning that I said any alphabet you will see while solving, you have to convert everything to be in line, to be either L, M, or T, that is length, mass, or time. I get me. So for this formula, L is here, isn't it? Yes. But B is not here. So meaning that B is what from the previous one we solved. Breadth is still the same thing as length, right? What of H? H means what? Height. So height, are we changing height to length or mass or time? Height is still the same thing as length. It's still the same thing as length. Are you getting it? So everything will now be length times length times length. This L times L times L. So L times L times L will be what? L cubed or L raised to power 3. L raised to power 3. I get it because you have 3 of them. Supposing it is 2, it will be what? L raised to power 2 or L square, right? But this one is 3, so it will be L cubed. 3 is cube, okay? L cube. Supposing we have 4, let's say we have L times L times L times L. Just count the number of L we have here. 1, 2, 3, 4, 5, 6. So it will now be what? L raised to power 6. Are you getting it? But here we have only 3, so please take note, okay? So L raised to power 12. So meaning that this is the dimension of volume. While L square is the dimension of area. Are you getting it? So this is how to calculate the dimension of different quantities. Now let's move to more complex quantities. Okay. Now let's say you are asked to find the dimension of velocity. Sorry, this is another quantity, velocity, right? Let's say from the previous ones we solved, let's say you are asked to find the dimension of velocity, right? I said the first principle is what? When you are asked to find the dimension of any particular quantity, the first thing that should come to your mind is what? Is the formula of that particular quantity, right? Let me write them again. The first one is formula. Then the second one is what the three approved quantities, right? Which is length, mass, and time. Let me just write the symbols: length, mass, and time, right? So take note of these two things. The first thing is what the formula, while the second is the approved three quantities: length, mass, and time. Now you are asked to find the dimension of velocity. Now ask yourself, what is the formula, which is the first principle, right? What is the formula of velocity? Are you getting it? That's why I said anything about physics, you have to understand formulas so you can easily attempt most of the questions. Now, the formula of velocity is what? Displacement all over time. Displacement all over time. This is the formula of velocity. Are you getting it? Displacement all over time. Or let's write it in short form. Let's say d displacement as a symbol of displacement, right? I feel you guys. Then time t as a symbol of time, right? Now, in the previous calculations, I said when solving for the dimension of any particular quantity, you have to what, change everything in order to correspond with these three approved quantities, right? Now, we've gotten time here, which is t, isn't it? We've gotten time, but look at d. There is no d here. You have L and M. There is no d here, right? So ask yourself, are we changing this d to either L, M, or T? That is what you should understand. Are we changing d to either L, M, or T? You can easily notice or identify that displacement is the same thing as distance. Distance is length. So meaning that displacement, we can change it to length. Are you getting it? Displacement is not mass. Displacement is not time. So please take note. Okay. If I write distance here, supposing the formula is distance all over time, meaning that distance, we can what, easily change it to length, because length and distance are they contain what, the same unit, which is meter. I get me. Displacement too is the same unit, meter. So we can easily convert this to what, length, which is L all over T. Are you getting it now? So we've applied the second principle, which is what, we have length here and we have time here. Are you getting it? So now this will not be the last answer. Are you getting it? This will not be the last answer. Okay, we have to change it. So we have L all over T, right? L all over T, right? So it will now be L T raised to negative 1 or minus 1. Are you getting it? Raised to what? Negative 1. Now, I know most of you will be confused. Ah, sir, how do you get LT raised to minus 1? It is very simple. This is law of math, like from indices. I get it. So, anything about physics, application of mass formulas is involved. Yes, application of mass formulas is involved. Okay. Now, let's say you have something in this form. Let's say you have something in this form, like let's say you have q all over p. Are you getting me? All over p. Now this is a sign of division, right? Like divided by, the way we are calling it in primary school now here, divided by abi here. But this one, this line too, this line is also a line of division, divide. Are you getting it? This line is also a line of what? Division. Okay. So for you to convert this to this form, now in the law of indices, there is something with one of the law of indices. It says that if the middle is division, then the exponent will be what? Negative. Are you getting it? If the division, sorry, if the middle is division or divide, the the exponent or the upper numbers, we will change it to what? Minus. But if the middle is times or multiplication, we will change the upper numbers to what? Plus. Are you get me? So since the middle is division here, we just what? Change it to minus and indicate it with 1. Are you getting it? So it will not be, if we first write the numerator, which is the up one, so it will not be q, then write the down one, p, signify it with 1. Let me show you another example. Let's say we have um let's say this one is 2, sorry, raised to power 2. Let's say we have q divided by p square or p raised to power 2. I get me. If you want to change it, it will be in this form: q, right? Then p raised to power minus 2. This minus is compulsory, you must write it. But this one, the first one, the first one, um, there was no square here. That's why we had what? Q p raised to minus 1, right? Meaning that there was no number in this place. If if there is no number here, this is how you write it. I get me. But here there is number here raised to power 2. So for you to write it, you must put this minus sign. Let's say we have 3 here, it will be 3. Let's say we have 4 here, it will be 4. Are you getting it? So this is how to change. So here we have L all over T. So since there is no number here, supposing we have numbers, let me supposing we have number, let me signify it with 2. Let's say we have L all over T square, meaning that it will now be what? Raised to power minus 2. Are you getting it now? So, but here there is no number. There is no number. There is no number. So you just indicate it with what? With minus raised to minus 1. Are you getting it now? So this is how to convert this. So this is a dimension of velocity. Are you getting it now? So this is a dimension of velocity, LT raised to minus 1. Okay, so all these questions you will see them. I getting it? You will see this either your test or your exam period. Okay, so let's calculate for more complex ones. Okay, let's solve for this one. Let's say you are asked to find the dimension of force. I getting it? Okay, so please take note of these two principles. These are the two principles we use to write any dimension. Are you getting it? So let's say you are asked to write or calculate the dimension of force. What is the first principle? Is to apply the formula, right? So you have to know formulas, so it's very important. You have to know formulas. Are you getting it? Now ask yourself, what is the formula of force? Now the formula of force is what? Is mass times acceleration, right? Mass times what? Acceleration. Okay. This is the formula of force, right? This is the formula of force, right? Mass times what? Acceleration. Okay. Let's use the symbol. The symbol of mass is what? Is m, right? M, okay, multiply by, you know, there is no formula of m again or mass again, right? Okay. Now, acceleration. You know that we can still split acceleration, meaning that acceleration has its own formula. Are you getting it? Any quantity that has its own formula, we will keep reducing that particular quantity. Now, this is what I'm saying. Acceleration, there is formula for acceleration now. Yes. So what is the formula of acceleration? Velocity all over time. Acceleration is what? Velocity all over time. So meaning that you won't include this acceleration again. What you write is the formula, not the quantity. I get me. So velocity all over time is the formula of acceleration. So let's just use the symbol velocity all over time. Do you understand? Eh, this is the formula of acceleration. The formula of acceleration is what? Velocity all over time. So meaning that you will not write this acceleration here again. You will not write it again. Are you getting it? This is the symbol of mass is here multiplied by, right? The formula of acceleration is what? Velocity all over time. Yes. So let's come down. So m, this is the mass, right? Multiplied by this v stand for what? Velocity now. So do we still have formula for velocity? Yes. And what is the formula of velocity? Displacement all over time. Are you getting it now? So this is step-by-step procedure on finding or solving for the dimension of any quantity. Are you getting it? So look at it. Velocity. So the formula of velocity is what? Displacement all over time. So meaning that you will not write velocity here again. Are you getting it? So meaning we are replacing it with its formula. Are you getting it? So displacement, displacement all over what? Time. Please take note. Don't be confused here. Displacement all over time is the formula of what? Velocity, right? But you note that we still have time here. This time, so this time we what? Bring it under divided by this time here. You know, this displacement, this is a symbol of displacement now, G, the first letter. So this displacement all over time is the formula of velocity. Oh. Are you getting it? The formula of velocity. But you know that we have not touched this time here, this t here. Uh, that's why we are bringing it under. Okay. Okay. So let's continue. Now we have m multiplied by. Now for us to solve this, you know, this arrangement is zigzag, isn't it? This arrangement is zigzag. So what we need to do, let's solve it separately. Or if I'm the one that is writing the exam, I will just write it in this form. Let me write it well for you to see clearly. So m time. If I'm the one, I will just write d all over t square. I know most of you will be confused. I don't understand, no. I don't understand. Yes, I know say you don't understand. Let me break it down for you to understand. This place is zigzag. Look at this M. The M is here. So I want to explain how we got this D all over T square. Let me write it out. D all over T all over T. Abi? But you note that these two things are together, right? Displacement all over time. They are the formulas, are the formula of what? Velocity, right? But this one is separate. This down t is separate. So let's write it in this form. We can also write it in this form, like displacement all over time divided by t all over 1. Are you getting it? Look at it. You know, when we have 2 divided by 2, this one is 2 divided by 2 now, isn't it? Meaning that we can also write it in this form, 2 divided by 2. It's still the same thing. 2 divided by 2, 2 divided by 2, they are still the same things, right? So now, d all over t, these ones are together now. The formula of velocity, right? Then we bring this one here. Now, this over 1, make it not confuse you. This one make it not confuse you. I getting it. Anything divided by 1 will still give you that particular thing. 100 divided by 1 is still 100. I getting it? It's still 100. 10 divided by 1 is still 10. Then any alphabet divided by 1, it will still give you that particular alphabet. Are you getting it? But in maths, we only divide, but in maths, we always divide by 1. Here we have two things, so here we must have two things now, meaning that we want everything to be balanced. 2, 2, 2, 2. Are you getting it now? I want to explain how we come about this d all over t square. Now, in the law of mathematics, if something is in this form, we have to change this division sign, this divide to times, this division times this division sign to multiplication. Are you getting it? It will not it will not be in this form, because if we keep solving in this form, it will not, like, the solving will not make sense. Are you getting it? So for us to continue with the solving, we have to change this division sign to what? Multiplication. And for us to do that, this is how to do it. We have d all over t here, right? This one, we write it d all over t. Then for you to change this division sign to multiplication, you will bring the denominator upward and bring the numerator downward. Are you getting it now? So it will now be multiply by 1 all over t. So once you interchange them, this division sign will immediately change to multiplication sign. Are you getting it? So please take note. Now let's multiply. D times 1 is what? It will give us d. Then t times t is what? Is t square. I've told you guys before, t square. So hope you've understood how we come about this d all over t square, right? So this how to, I think um I've broken everything down for you to understand, right? So this is what we have, m times d all over t square. Let me clean this part before some of you say, hey. So here we have m times d all over t square, right? So from this, we can write it in this form, right? M times d all over t square, m divided by 1, isn't it? It's still the same thing now. It's still the same thing. I said anything divided by 1 will still give you that particular thing, right? So please take note. Now m times d will give us what? Md all over 1 times t square will give us what? T square, right? Now from the approved stereo quantities, look at it. Do we have m? Yes, m is here, so we are done with m, right? Do we have time, which is t? Yes, we have t here, isn't it? But is d here? D is not here. So um this and this stand for what? Displacement, right? So are we converting d to l, m, or t? Is l because displacement can be interchanged towards distance, okay? Because all the units of both distance, displacement, length, all are measured in meter. I get it. So you can interchange it towards to length, okay? So it will now be in this form, m l all over what? T square. So are we leaving it in this form? No, like the previous one we solved. We what? Bring this one upward. So for us to bring this one upward, I think I've explained this for you guys, right? So now be m l t raised to what? Negative 2. Yes, because we have 2 here. When bringing it upward, supposing there is no number here, we'll have just write raised to what? Minus 1. But this one we have square here, so we indicate it with negative sign, then put this 2. So this is the dimension. This is the dimension of what? Force, mlt raised to minus 2. Are you getting it? This is dimension of force. Now I'm solving everything, like giving you guys explanation, like detailed explanation without looking book. I'm not with any book here. I get me. So I'm just writing. So this is how you will see it. Now one thing you should understand is take note of this. This is always in form of expo. Now in the exam, because exam you have like 30 questions for 30 minutes. Are you get me? Meaning that one question carries this thing 1 minute. We use 1 minute to solve one question. So you have to be very fast when you are solving. Limited time, okay? So now in the exam, you are given this type of question. What is dimension of force? I get it. And you note that mlt raised to minus 2 is a dimension of force, right? In the option, you can just go there and tick this one. So meaning that if you keep solving, this thing will enter your head. I get it? Because if you start solving from the beginning, it will take a lot of time. Because some of you will be very slow in solving. That is it. Some of you might take like it might take you like 3 minutes before you can get this answer. But if I'm solving, it won't take me like few seconds, I'll be done. Yes, few seconds, I'll be done with this type. Okay, so if you keep solving, all these dimension of volume, dimension of area, dimension of force, dimension of pressure, dimension of this, all these things will be in your head. So if you see any question on a dimension, you just go to the option because you have been solving every day now, you have been practicing every day. So all these dimension will be in your head, right? So it's for you to just go to the option, tick the right answer, go to the next question. Are you getting it? Okay, I'm giving the guys assignment. Okay, solve this assignment. Okay, the dimension of pressure and the dimension of Young modulus. Are you getting it? So dimension of pressure, dimension of Young modulus. Now, um, apply these tools. Please don't forget these tools. So these are the approved tools. So please don't forget them. So dimension of pressure. First, know the formula of this pressure. I get it. Then try to split anywhere that is necessary. Okay. Then dimension of Young modulus. Know the formula. It's very simple. I get it. It's very simple. So you will submit it. I will um I will drop on when to submit in the group. I get it. I will drop on when to submit in the group. So please take note.